Let's see what this guy has in store for us. Premature optimization. I suspect I won't like it. Hopefully it will redeem itself.
I truly do believe that premature optimization is the root of all evil.
Cool intro. Overused quote.
Most conversations about performance are a total waste of time. Not because
This is probably true, but let's see where he goes with this.
performance isn't important, but because people feel very, very strongly about performance. I tend to think of performance as an element.
Wait. If that were true, why is all the software so slow? I mean, I guess it could be true. Then people must know nothing about performance, which maybe the video will tell us why that is.
Of this trade-off triangle. Velocity here is how quickly one adds new features, and adaptability is how well the system can change to new requirements. You might think that velocity and adaptation go hand in hand, and they do, but sometimes one can hurt the other. Focusing on pure velocity means hacking together something as fast as possible, taking the shortest path to the feature. Future maintainers be damned. And at the beginning, you'll gain a lot of immediate velocity as you hack things together. But as you do this, you're creating a bunch of technical debt, which will weigh you down to.
I don't believe in technical debt, really. I never suffer technical debt while trying to do this technique as much as possible. My suspicion is, well, I have a friend he's described to me some real technical debt. And I think it's just when you throw... The real answer is you throw a bunch of bad developers on something, and then it can become a hideous mess. But if you're a good, skilled programmer, things don't become a hideous mess when you're trying to get stuff done as quickly as possible. Because that would slow you down, so clearly it's counterproductive. But you are always trying to... If you're doing the minimal possible thing to solve your problem, which is how you have the highest velocity, that's also how you build the most robust thing, is you do the simplest thing that solves the problem and nothing else. And that actually produces the most adaptable code as well, because now you have the least amount of code volume and the least amount of extra constraints, so you can sort of rotate into different things. But let's continue.
Halt. Adaptability is about writing the code in a way to enable changes as new requirements come in. Think creating reusable, extensible components.
That's called writing a library, okay? Like I said, to make the code that's the most easily flexible for new requirements that might come in is the dumbest, simplest code. It's the smallest code that solves the problem. Because if you're dealing with simple code, like worst case, you could just rewrite it again. If that's quick, then you have an infinitely adaptable piece of code, because you just delete it and then rewrite it again. And you can rewrite it into anything else. What he's talking about now is writing a library, which I guess is ideology. People believe that they should be writing libraries when in fact they're writing applications.
Beautifully crafted interfaces and configurability. With the right designs, you can increase velocity by reducing the size of changes needed to add new features. But if you make things too adaptable, you also hurt velocity. If you had a crystal ball and could see the future, you'd be able to know exactly which use cases you need to design for, and also which ones you don't need to design for. But when you build a highly adaptable system that can adapt to a whole...
I mean, this would be... I'm just repeating a budget Mike... I'm being a budget Mike Acton here in saying you can never future-proof something. So he's correct here that, if I could see the future. Well, no, the point is you never see the future. So don't do this garbage. Just solve the problem you actually have. You'll be way more productive. And you'll be productive because you don't perform waste work, which I guess is what he's pointing to here. Yes, if you make a library... If you think that writing a program to do some task means actually writing a bunch of sub-libraries, with lots of extra functionality that you maybe might need, yes, that is wasted time.
Whole bunch of cases that never happen, then all of that just ends up being a big waste of time. With highly extensible systems, you also hurt performance. Adding lots of adaptability naturally adds more abstraction and indirection in your code, which usually has a negative impact on performance. But this trade-off is usually worth it because of the adaptability it allows. You might think you always want something in the middle, but I actually believe this depends on the stage of your project. A feature-complete game pushing final ship date would focus on performance. You might be okay with reducing the velocity of new changes and adaptability in order to squeeze out the last little bit of performance. But when a game...
If your game starts out development at 4 FPS, it's just over. It should be something like 4,000. But disregarding that, you can absolutely not just optimize the game at the end. In order to ship a game that hits targets, say, oh, we have to run at 60 FPS on this machine, that constraint is going to inform all your work, from art pipeline to, even what game you make, because what game you make and how that game is going to be made on the platform informs everything. So you can't do performance at the end. Maybe you do try to optimize at the end, but you have to have been thinking about performance the entire time. Otherwise, you're just not gonna ship. You can't magically, if you the way to increase the performance of the game is to start over and write a new game that runs at the higher speed. There's no, sometimes you could tweak and update things, but often that's not the case.
As earlier in development, you might focus on getting more features out quickly, or building up an extensible system that lets you tweak the game freely. When Mark Zuckerberg wrote Facebook...
So again here, there are kernels of truth, which is why it's convincing. You do want to ship functionality, but that's always a priority. And because if you don't do that, then you run out of money and you don't ship. And then maybe if you're doing that game design, you could consider if we rotate the suggestion here to say, oh, in my puzzle game, do I invest in making a level editor? That's not code adaptability at all. That's something different. But if I invest in making a level editor, does that allow me to make levels? Yes. That's more about like tooling for velocity. I wouldn't actually call it. You put it in his triangle.
He did it in PHP. PHP is an awkward language, to say the least, and it gave Facebook a whole slew of scaling issues as Facebook grew. They ended up making a PHP to C++ compiler, and later when that hit a performance plateau, they basically created a dialect of PHP called Hack. But would Zuckerberg be better off if he wrote it in highly optimized C code to start? No, I don't think so. I think writing in the inconsistent, inefficient PHP was the right move, because it meant that he could build Facebook quickly. Once performance became a real problem...
I would argue here that he used the tool that he was good at to make the product. And that's, shipper, we like that. But could you, if I had to make the same program and I was given PHP or C, I'd be tremendously more productive in C because that's the thing I know and I'm used to and can get a lot of stuff done in. So, I guess use the tools that you are good at.
Engineers went to solve it. If he focused on choosing performance over velocity, it's not clear that Facebook would have taken off, and Zuckerberg wouldn't have had the privilege to visit Congress as much as he has. So, the key with the triangle is that performance is a problem, but it's not usually the first problem, and you should be deliberate about which way you're leaning.
That's probably true.
It's useful to differentiate performance issues into two camps: macro performance which I think of as design level performance. These are system-wide performance considerations. And micro performance, which is fine-tuned performance. This could be looking at the perf of a single module or function. Premature optimization usually occurs for micro performance. This is typically where someone comments in a code review.
So far, I do not recognize anything here, or at least in terms of my own understanding, real-world understanding of how things work.
That you should do X instead of Y because X is faster than Y. But computers are really fast. I have some Python code that helps me generate the code animations for this series, and that Python code does some horrific stuff. Each character in my code is basically in a big array, and on every frame I just linear search through it to find the relevant characters. And it still renders me out a video fast enough that it's not worth making it any faster. At the end of the day, you're writing code to solve a real-world problem. And typically getting to the solution of that real-world problem faster is better than solving the problem slower with faster code. Let's look.
But he could have written it not in Python, and then presumably, at least in my opinion, been more productive because he has actual type checking on his code. And then if he chose to compile language, his end program could be 1,000 times faster than his Python program. So if you can score, going back to the triangle, I think it's about when people make a triangle like this.
What do you mean?
The problem is you can create a false dichotomy where, I want velocity, so I have to, in order to increase my velocity, I will decrease my performance because that gives me higher velocity. No. You can be really good at all the things at the same time. So instead of trying to say, but computers are fast, I don't have to care. No, you can. It's just with skill, if you're good at what you do, you should be able to do all of these things at the same time. It shouldn't be a trade-off.
Has 4 extra assembly lines to make a copy of the iterator.
And I guess we skip forward.
Gotcha. Look at the difference between that it is indeed faster. Opponents of ++i will say it's faster because technically I++ needs to make a copy of the value, since when it's part of a larger expression, the incrementation needs to happen after the expression is evaluated. This one gets me.
It's weird to use ++ in this
You
way,
might say, but code aesthetic. If it's faster, well then why don't you just do it? Why don't you just always do ++i? Because, sir, madame, think of the precedents. I don't know for a fact that it is indeed faster. And so should I blindly trust Daryl because he thinks it's faster? No, of course not. So now I need to go through and do a thorough and lengthy investigation into the distinction between I++ and ++i. Now I gotta go and disassemble it. I write a for loop with the pre-increment operator and look at what it does. Okay, here, it loads the value from I into a register, EX, then adds 1 to it, and then puts the result back into memory for I. Okay, seems straightforward, so let's look at post-increment. And it's identical. You get the same code for both. Okay, but this is just an int. What if it's an iterator? We have a vector, which is just C++.
You already lost. What? You failed because you're using C++ iterators. Like, this is crazy, but okay.
Plus versions of a list.
Or say the real, he's talking about macro optimizations, I guess. The real micro optimization is don't use iterators in this way when you could have used a for loop.
And you can access the elements of the vector through an object that overrides the two ++ operators.
That's again. As soon as you say object or like the class wrapper iterator, this should be setting off warning lights. This is the appropriate. I guess we'll talk about it later.
The post one would need to make a copy, right? Well, let's look. Aha, gotcha. Look at the difference between these two long functions. You'll notice that this one calls the function for the post, and this one calls the function for the pre. And the post version of this has 4 extra assembly lines to make a copy of the iterator. And it calls into the other operator. So you got me. It does cost a little bit more to do I++. Except when you turn on optimization, those function calls completely disappear and you end up with identical code for both cases. So now the answer is a thorough and totally satisfying maybe. We must measure. After measuring the difference on my MacBook, the speed of the slowest increment...
Okay, this is true. You have to measure, but you could say one definition of programming skill would be to know, if you were a high-skilled programmer, that means you know more things, you have more intuition to apply when doing your work. And so compared to the noob doesn't know anything. The noob must measure. But you, like as a good programmer, you should be accumulating intuition so you can just so that you can pick more wisely to win overall, so that you can score highly on all 3 sides of that triangle.
Is 3.4 nanoseconds. If you notice the little counter below, this is how many worst case increments have occurred since I started talking about this. Is my increment really going to execute this many times? Is my code going to even ship?
He's incrementing that fast, yet he can't make his he can't make the number update more than like once per second.
Will my startup fail? I spent 3 hours on this investigation. Could have spent 3 hours building the best dog walking app known to humanity.
Okay, let's go back to this iterator example.
And you can access the elements of the vector through an object that...
Okay, this is the craziness. The problem with premature optimization is that, yes, it is not worth having the debate on how do I in C do the addition because it's going to compile to the same add instruction. Okay? It's all the other stuff you do that is killing you in terms of performance. It's why you don't, I almost want to say you don't get to complain about premature optimization when all your stuff is garbage slow. If the thing you made was fast, then I'd believe you. But since the thing you made is so hideously slow, most software is objectively very, very, very slow, then what do you know about premature optimization? Clearly you don't know what you're talking about. Yes, how to add the integer is not a good conversation, but it's all the other junk that you're doing is just this waste. And I guess this kind of mentality doesn't make you a talented or skilled programmer. So what we had, yeah. This is true though, what he's about to say now.
So my point with this is that you should ask yourself, is this conversation even worth it? If it brings you joy to figure out which is technically faster, go for it. But I don't think this should end up on a code review, because it doesn't.
Don't have code reviews. Why, if we go back to the triangle, velocity, why does somebody have to review your code? Just commit the code. Surely you trust the people on your team to make code changes. That's how you get things done quicker. But we'll continue.
Doesn't matter. Otherwise I have to go through this whole thing again. I like I++ because I think it looks prettier. And until someone tells me that we can't ship because our app is too slow, and we've measured that the solution is to change all of our I++'s to ++i's, I'm sticking with it. This also applies to functions. In many of my previous videos, I've argued about using extraction to help readability.
The problem there is that his app can still be really bad and it won't stop ship. Like, you'll ship the bad app, you'll just have a bad app. And then you could have had a good app, but you have a bad app, and then until somebody, I guess, measures that, like, oh, we showed people the good app that we don't have. We compared it to the bad app, and they all said they preferred the good app. So you're not going to make the good app because you don't have it, so you can't measure the change in user behavior.
Some have argued that functions are expensive, but rarely has the cost of a function been so significant that removing the function is the solution to a performance problem. And in the rare instance that it was a solution, it doesn't mean that it's proof that it's worth the readability loss by default.
In most cases, in my opinion, extracting to a function is a readability loss because you lose context. You actually much more want the context of why is this code doing what it's doing. If you have a function that's being called from only one place, it should probably be just in there in the code.
As a solution, it doesn't mean that it's proof that it's worth the readability loss by default.
So this is just not. But
a big issue
of course,
with making
personal
performance
preference.
rules to follow is that often the rules have a lot of exceptions.
True.
Here we have a class that keeps track of the currently logged in users. Our first implementation just has an array which contains a list of users. Then we have this logged in method which returns whether or not the user is logged in. It has a simple for loop which looks through the list searching for the current user. During a code review, someone says, hey, this thing is slow. You shouldn't just search the list of users like that. It's slow and you should use a set instead, a data structure that lets you look up unique elements much faster.
The problem here is he's also in Java, so the hash set of an integer, and the integer is now a class, so it's going to be heap allocated out, and so it's automatically way slower for a different reason than the one I bet he's about to mention.
A data structure that lets you look up unique elements much faster. But when you measure the difference, you actually find that set is slower.
But again, you're not comparing the two same things. I'm not arguing for the set, by the way. The array is the right choice, but the array here is faster for more reasons than one. And actually, your job as a programmer is to, over time learn these things so that you can make the appropriate decision given the real world problem you are solving.
Only have a few users logged in, which is normal for your system. I'd speculate this is because our integers in the array are right beside each other in memory, and the implementation of set likely allocates objects in lots of different places in memory, reducing cache hits. But like I said before, until you've shown that this function specifically is the leading cause of your performance issues, go with what's more readable. So I do think that set creates cleaner, more readable, and less bug-prone code. So I'd go with that.
Okay, I was going to say, but people want to push set the whole often. But of course that's what he's doing because he's, I don't know, code style over real world
There's so many
application
factors
guy.
to performance that there's only one way to properly optimize. Measure, try something, measure again. Measuring is critical because, like we just showed, your assumptions of what will make things faster can make things slower. You can help form a hypothesis of how to make things better by doing an analysis. Data structure selection by far is the most important, and that's because choosing the right data structure can give dramatically better results over the wrong data structure. When dealing with performance issues, I tend to think in terms of 80% moves first. What are changes that could have an 80% reduction? And often, the only thing that can get you that far are data structure changes. Once you've implemented them and measured the difference and still see it's not good enough, then you have to look at the smaller things. You might not know where to start, and that's where you'd want to look at the profiler. A profiler can tell you what are the hot spots of your code. It can point out functions that are the most expensive.
Yes, this is true, but if you have to use a profiler, again, as part of being more skilled is not having to reach for the tool, just having internalized good intuitions about these things. That said, he's right about the data structures thing. Although you should probably use the profiler to figure out if something is being slow.
Expensive. There was kind of a funny story about Grand Theft Auto 5 online. It was so slow to launch that one player, who goes by Tost, wanted to figure out why. Even though they didn't have the source code, Tost used a profiler to figure out why it was so slow. It turned out pretty much all of the time was spent parsing and processing a JSON file. A patch to fix just that one part improved the load time by 70%. That's the funny thing with performance, is that sometimes when things are slow, it's just one silly thing slowing everything down.
Guys, the funny thing with performance is if you shit the bed, then you have to deal with that first before you can do the real work. If you ruin the game's load time by doing a crazy JSON parse, then you have to deal with that before you can actually make it fast. I don't know what the takeaway is. I guess if you want free wins, if you want to sandbag, add slow stuff to your program. And then that'll be most of the runtime. Oh my god. You can fix that. Feel good about yourself.
For GTA 5, all someone had to do was look. After data structures and profiling, then you just have to start making educated guesses. Thinking about how your code could be working underneath the hood and find ways to simplify stuff. A lot of performance comes from how your code uses memory. Allocating memory, which is done whenever you make a new object or array, can slow things down in critical sections because the system has to find free chunks to put stuff. You'll get a lot of speed for having critical elements close by in memory because things are much, much faster when they're in the CPU's cache. But again, I wouldn't worry about these things until you know you have a performance problem and have tried other things first. So when you optimize, first,
I've run out of energy to comment. I mean, yes, it's like, yes, that's true, but also it's wrong. Like, you should care a little bit, at least. Please.
Have a real performance problem, then measure it. Try to make 80% moves by swapping data structures or moving to a well-known, faster algorithm. Profile and find hotspots. Then worst case, start thinking about what your code is doing under the hood. What are some interesting cases you've hit while trying to make code faster?
I guess you guys should go support this guy's Patreon because he made this nice video. Anyway, that's it. What did I think about this video? I mean, it's wrong, but it's less wrong than you'd think. It's one of those, like, I can't really complain that much because compared to the large volume of programmers, this is still kind of okay, although it's quite noob still. Anyway, that's it. If you like that, you can check out my stuff at samhsmith.com. See you guys in the next video.